Cal Academic 3.1 lecture. The date is Tuesday, November 15th. No, middle light needs to come off. Yeah, do that. That's fine. There's a bit of a glare, but it's okay. All right, so we're moving on. This unit is all about exponential and logarithmic functions. So hopefully you remember that. Okay, do you have a lanyard or no?
It's in my car.
Okay. I don't want you to go to your car either. Remember tomorrow, okay? All right. Label as a power function, exponential function, or either. Or neither, sorry. So which one of these are powers and which ones? I'm gonna highlight the pink ones that are power functions. Which one should I highlight? Anyone have any idea? All of them? Not all of them.
The first one and the third one.
Power function. Power function. So the first one, yes, that's a power function, okay?
And the third one.
Third one is a constant function, so no. That's going to be neither.
Does it have to have
Has to have an x, yeah.
So the D is as well, right?
D is a power function, yep. D is a power function. Yep. So it has a power function if there's a base, there's an x in the base of an exponent. It's in the base. The base of an exponent is like the number that like gets raised. Does that make sense? Does that make sense? Right, so x to the 8, the exponent is 8, the base is x. Okay? Okay. Right here, right, there's an exponent, x to the x, okay? X is in the base, so that's a power function, okay? And then this is a neither because there's no x. There's no x at all, okay? And then help me label the exponential functions. I'll label those in yellow, highlight those in yellow. Okay, how do I do that? So exponential function means there's an x in the exponent. Okay, so which of these have an x in the exponent? B, and what else?
D.
D.
So
Okay,
it can be both.
so D is both. And then this is an exponential, expo, and this is a power. Okay, we feeling okay? All right. Good. Okay, this is pretty simple stuff. Okay, 2, you literally, so find the value of the function for the given x value. You just plug in the x. So for this one, they want f of 0. Okay, so f of 0 is just going to be 3 times 5. Then instead of x, it's going to be to the 0. Okay. Okay, this becomes 3 times, what's 5 to the 0? 1, which equals 3. Okay. All right, what B? Someone tell me what B is.
2. Oh wait. That's not 2.
So you guys see how I plugged it in? I just, wherever there was an x, I put a -2. What's 3 to the -2? This is order of operations. What's 3 to the -2? 1/9. 1/9. So 6 over 9 or 2/3. All right. Same here for C. I get f of 1/3 equals -2 times 3 to the 1/3. How are you supposed to do it? No calculator. Don't really.
Don't you put? Wait.
Okay, Miss White just left it like this. She just left it like that. You can't do that without a calculator. The farthest you can get without a calculator is just plugging in 1/3. Then you have to stop. Unless you want to like come up with your own numerical method that you want to use by hand, which that's what we're doing in calculus. It's pretty awesome. And before calculators, the mathematicians had to come up with their own way of like finding how to do stuff by hand. So they came up with special stuff. Anyway, all right. So
Special education.
use power series. Anyway, we're not gonna learn about power series in here. Okay. And then D, f of -3 halves. Okay, -3 halves. Let's plug it in. That's the easy part. Right, we got to figure out what 4 to the -3 halves is. So what's first thing I can do to deal with that 4 there? So get rid of the negative exponent, so that becomes 1 over 4 to the 3 halves. Then how do I calculate what 4 to the 3 halves is? Let's make a side note. Do you guys remember from Algebra 2? This is a read from Algebra 2. When you have, okay, a to the b rooted to the c is the same as a to the b over c. Okay, so write that down. Okay, so we have 4 to the 3 over 2. So then 4 to the 3 over 2 equals what if we just plug in the numbers? Four to the 3 over 2 is going to give us what now? We should know this. No. So 4 to the 3 over 2. So we have 4. A is 4. So it's 4 raised to what? 3 rooted to what? 2. Square root. Square root of 4 cubed. Okay. What's 4 cubed? What's 4 cubed? 4 times 4 times 4. 64, yeah. What's the square root of 64? 8. So this becomes 8 times 1 over 8, which equals 1. Oh, I'm sorry, Matt. Matt, were you saying like the answer to the problem is 1? Oh, yeah, you're right. You're way ahead. Way ahead of us. Hey, are you guys okay with that? So just remember that. I think the only one thing that like really threw us off was this guy right here. Okay, so just remember that. Okay, that's from Algebra 2. I think it's what, chapter 6 or 7 from Algebra 2. All right, so write the equation number 3. Write the equation of the exponential function where f of 0 equals 3 halves and f of negative 2 equals 108, okay? Anyone have any idea how to do this? No. You're on the right.
Would you just get the...
So the standard form, to do this I have to give you guys something. So the standard form of a line, what's the standard equation for a line? Y equals mx plus b. What was the standard equation for a quadratic?
Oh, y minus y plus.
Right, remember this vertex form? Okay, the standard equation, the standard form of an exponential, standard form of an exponential function, of an expo function is going to be f of x equals a times b to the x. Standard form. Standard form of an exponential function, okay? All right, so let's highlight that. That's important. Okay. So what we do here then for this problem, right, is they give us f of 0. So we're going to use f of 0. We're going to use that to find, what are we going to find? Use that to find a. Use to find a. Okay? Once we have a, we'll use this second piece of information and plug everything in to find b. Use to find b. Okay? So let's do the green stuff, okay? So f of 0 equals 3 halves. So if we know we get 3 halves if we plug 0 into this equation, okay? So we just plugged everything in, okay? What does that b to the 0 become? 1. So what am I left with? A equals 3 halves. Okay. The right side is just a times 1. Good? Okay. Good. Good. So that's 3 halves. Now we go to the pink stuff. We plug everything in. So what do I plug in for f of x here? Silas? And negative 2 is my x. What do I plug in for f of x? What does it say f of x equals? 108, yeah. What do I plug in for a? What do I say? What did we say a is equal to? 3 halves. Right? Do I know b? I don't know b, and then what do I plug in for x, Silas? Negative 2, yeah. For x, I plug in negative 2, okay? Now, you guys see this? right here I have one equation with one unknown, just b, okay? So I gotta solve for b. Okay? Alright, so a couple ways we can do this. So we want to solve for, we want to get b by itself, okay? How do I get b by itself? What do I get? Gotta get rid of first?
Explain it.
I'm going to get rid of the coefficient first. So how do I get rid of that coefficient? Multiply by 2/3. Okay. Okay. Someone help me out. What's 108 times 2/3? Yeah, 36. No, 72. 72. 72. Someone help me out. Madeline. 72 equals b to the -2. Okay. If you're comfortable doing it, you can do this. I would do this, just raise both sides to the -1/2. If you guys aren't comfortable with that, you can just rewrite this as 72 equals 1 over b squared. Okay, multiply both sides by b squared. You get 72 b squared equals 1, or b squared equals 1 over 72, or b equals the square root of 1 over 72. Which I believe is, are you done?
Yes.
Sweet. You can pass back.
Yeah, probably.
Okay.
Thank you.
Mr. Spurgeon real quick.
Thank you.
Yep. Good. And then 1 over 72, that's 1 over the square root of 72, which is 1 over 6 root 2. Okay. Are we supposed to rationalize our denominators? Looks like we are. So then we want to rationalize this denominator, so we multiply top and bottom by root 2. That gives us root 2 over 12. Finally, so then so this is our b here. Don't forget where we were going. That's our b. So then we plug everything in. We get f of x equals a. What was my a? 3/2. What's my b? Root 2 over 12. Then to the x. Let's put parentheses around that and do to the x. So my final answer is in yellow. My final answer. Okay. How are we feeling about that? We feeling okay? Kind of a lot, but I think the various steps weren't too bad. It was a lot of it was very similar to what we did with vertex form, right? Vertex form of a parabola. They say, hey, there's a parabola whose vertex is this, and this is a point on it. We'd start plugging stuff in and solving for the letters we needed that we didn't know, right? All right, so repeat that same thing, okay? So we start with what?
Zero.
So,
0 equals 3.
yeah, we start with that. Good job.
F x equals a times b to the x.
Yeah. So start with the standard form, a times b to the x, okay? The green, and then we're talking the green. So what do I plug in for f of x, Jack?
3.
3, and what do I plug in for x?
0.
0, okay?
So is it basically just gonna, if the f of whatever is 0, is it just gonna equal whatever?
Like whatever's on the right side of the equal sign? Yeah. So a is equal to 3, okay? Then I use that over here. Okay, so I plug everything right here. Okay. So Colleen, what do I plug in for f of x?
You disappeared.
So
It's gone.
what? Oh, sorry. What do I plug in for f of x here? So I start from the standard form, right? And I know f of 2 equals 6. So they're saying when I plug in 2 for x, I get 6 out. So what do I plug in for f of x?
2.
6. That equals a. What's my a?
3.
Let's let Colleen answer. What's my a, Colleen? 3. Then do I know b? I don't know b yet. What do I plug in for x? 2. F of 2 equals 6 means when I plug 2 into the standard form of my exponential equation here, I get 6 out. Gives me an output of 6. Okay, so we'll keep working on that. And then I want to solve for b here. I'm trying to find b. So we use the green equation to find. So what's going on here, Colleen? Do we start from the standard form of an exponential function? Okay. And then what's going on here is we use the stuff that I highlighted in green to find a, and we use the stuff that I highlighted in pink to find b. Okay. So to find a, they gave us f of 0 equals 3. So when we make x 0, we know f of x becomes 3. So that gives us this equation where b goes away because b to the 0 is 1, and then it gives us a equals 3. Okay. All right. So that's what's happening. And then we use that a. We plug in over here. We plug in our a. We plug in our f of x, and we plug in our x to give us an equation that we can use to solve for b. So when we solve this for b, we divide both sides by 3. We get 2 equals b squared, or yeah, b equals the square root of 2. B equals the square root of 2, and then our answer, we just plug in our a and our b into the standard form equation, okay? So our answer is f of x equals 3 times the square root of 2 to the x. So that's our final answer. Final answer. Okay, how are we feeling about this? So? Yeah, so this is something I think we can improve on a lot with practice. We have been doing this for 5 minutes. So if you're feeling so after 5 minutes, I feel pretty good about that. I'll take it. We'll get better as we practice on the homework and whatnot, okay? I need to sit down. All right, so describe the transformations of f of x equals 2 to the x in Sketch, okay? It's probably a good idea. To show you the graph from the original parent function, which I'll do now. Okay, so all right. So here's the original parent function. Right there. Okay, that's my parent function. So let's draw that in real quick. So what this looks like, and we talked about this on the BFF. I'm just going to draw the parent function here in the middle. So it's going to intersect. What's the y-intercept for one of these? Yeah, it's going to be what the coefficient is. So 2 for 2 to the x for y equals 2 to the x. It's just going to be 0, 1. Okay. So that's my parent function, okay? And then this should actually be pretty simple, guys. So do you guys remember what if we had f of x minus 3 and that minus 3 is inside of parentheses, what did we say that minus 3 does to our graph? It moves to the right by 3, right? And then a minus 3 outside parentheses would do what? Minus 3 outside of parentheses would move it down 3. And then a minus 1 times that would flip it, okay? So we're going to have a similar thing going on here, okay? But instead of looking at whether x is inside or whether minus 3 is inside or outside of parentheses, we want to look at whether or not it's inside or outside our exponential, okay? So having said that, what do you guys think I'm sorry, that was Maggie's test timer. Having said that, what do you think a minus 3 inside of our exponent is going to do? So inside our parentheses was to the right. Inside our exponential, inside the exponent would be what? it's going to move us right by 3, okay? So this will move us to the right by 3. So we'll have point 3, comma 1 on here. Okay, does that make any sense? So I just got moved to the right.
Rusty. Second one today.
Still sounds fun.
Oh,
Wait, she was looking for it in my last class. I just had the last period she was looking for it. I'll send her an email. Don't worry about it.
Nah, he needs to go see
That's
songs.
so funny.
Call up songs. He's stealing.
But that's project.
But the last period she was like trying to look for it.
Sounds like that's
He was
not
like,
me.
he couldn't find it. First thing he was on a broadcast, he got a Geo. He just like was.
That was awesome. That's so funny.
That was.
I thought it was Blair.
Did you just steal their phone?
No, I
I don't think so.
Oh, is it just in your
How do you take that
don't
photo?
think so.
Wait, that's an SMC.
All right, 2 to the minus x then, okay? So, we didn't talk about this actually. I don't know if we talked about this. So, did we ever talk about, if we have a minus f of x, there's a minus outside the parentheses, what did that do? A minus 1 times f of x, what did that do? It flipped it over the horizontal axis, right? Did we ever talk about if you have a minus inside the parentheses, if you do minus x, what that does? No, so what this does is it flips it left and right. Flips it left and right. So, yeah, it's a mirror. Yeah, so if there's a minus then, that being said, if there's a minus inside of my exponent, what's that going to do? It's going to do the same thing, flip it right to left. So it's going to flip over the vertical axis. So now it's going to look just like it did, but backwards. It's called exponential decay. This stuff is big. This is big. Very important stuff. Okay. C. What's a minus? Then again, my minus is outside my exponents. What's that do? Flip over what? Horizontal, yeah. So just like my parent graph, except it'll be flipped in the horizontal axis. Okay. All right, and then that D. So what's the plus 1 going to do? I think we know what the plus 1's going to do. It's going to pull it up 1. Yeah, good job. Good job. Good job. And then there's a 1/2 in our base now instead of. There's a 1/2 in our base now instead of a 2. What do you guys think that's going to do? What do you think that's going to do? Yes. So it's not going to shrink it. Let's think about this. What's 1/2 equal to? Is 1/2 a power of 2? 2 to the what equals 1/2? 2 to the negative 1. So this is the same thing as y equals 2 to the negative 1 to the x plus 1. What's 2 to the negative 1 to the x? How do I simplify this with my exponent rules? This is for algebra 2. It's going to be 2 to the negative x plus 1. Okay? So what happens then is we get flipped, right? That negative x inside, that negative inside of our exponent, that's going to flip us left to right like this. So it's going to be the same as this graph, but just shifted up by 1. Okay? So flip over vertical, shift up 1. intercept will be 0, 2. Can you guys see that? So just some graph transformations. Okay. All right. Good. Okay. You guys feeling okay about this? Okay. 5. State whether f of x represents growth for decay. Describe its end behavior. Okay. So here's what goes on here. Okay. All right. So how do I want to write this? How do I want to explain this? Okay. So I'm gonna make a little chart. Okay. Okay. I'm gonna make a little chart. So let's do base. Right. That can be either a fraction. Integer, fraction, or whole number, I'll say. Okay, and then the exponent is going to be positive or negative. Okay. Okay, if the base is a fraction, the exponent's positive, it's going to decay. It's going to be an exponential. I'll write this in a different color. It's going to be decay. If the exponent is positive, you have a whole number in the base, it's going to be growth. Okay, if the exponent is negative and you have a fraction in the base, I believe that's going to be a growth. Okay, and if the base is a whole number and the exponent is negative, it's going to be a decay. Okay. All right. So 3 to the x then, which case is this? The base is what? Whole number. The exponent is what? Positive. So whole number, positive, is going to be a growth. So growth. So what does that mean then? If there's exponential growth going on, what does that mean? 2 things. So the limit as x goes to the right forever is going to equal what? Exponential growth. So what's going to happen? It's going to go to infinity. It's going to shoot up. Right? And then the limit as x goes to negative infinity is going to go to 0. Okay? For decay, you just flip those 2 things around. Hey, Blair. It's on my desk.
Oh.
Glad you found it.
Who was it?
I had it. I had it the whole time. No, I'm kidding. You wait.
Well, it was on the ground in the anatomy room.
You want me to cover for you?
You
No.
did? No, I was looking for it.
She was looking for it.
I thought you were gonna say something.
Wait, you thought I saw you?
Alright, we're good.
Yeah, we're good.
Alright, we're good.
Take it easy, bro.
Wait, was it in the class? Or
Alright.
the whole class?
No, you're good, Blair. You're good. It's cool.
Alright, so for B, let's get us.
Yeah.
I
What's that?
appreciate you.
You're already
so much.
covered.
Thank you for on my back. I appreciate you.
3 to the negative x. You weren't actually trying to steal it. You
No,
wouldn't have
I
given
was
it back.
not trying to steal.
Yeah, you wouldn't have given it back if you were actually trying to steal it. Okay. Base is a whole number here or a fraction? Ava Jordan is a whole number or a fraction?
The base.
Yeah.
Whole number.
Yeah. What about the exponent? Is it positive or negative? Negative. So it's going to be a decay. It's going to be a decay. Okay. And then so decay, we said what? It's the same as growth. The end behavior is the same as growth, except what? Yeah, it's just flipped around. It's flipped around, right? So as our graph goes to the right forever, it approaches 0. As we go to the left forever, we blow up to infinity. Okay. C here? What about C? So Maggie Melbrook, my base is what? A fraction or a whole number? My exponent is positive or negative? So it's decay. It's decay, right? Right. Another way of thinking about this is this function is equivalent to 2 to the negative x. If we just flip the sign on the exponent, we can flip the fraction inside to its reciprocal, so it's 2 to the negative x. So the limit as we go to the right forever is what, Maggie? It's decay. We're going to the right forever, it decays. What's that? 0, yeah. And then what's the limit as we go to the left forever? Yeah. Good stuff, good stuff. And then this last one here, Michael Williams, is that going to be a growth or a decay?
Growth.
Good job, yeah. Crushed it. Right, this is the same thing as 4/3 to the x. Okay. I guess maybe instead of writing a fraction here, I guess it's fraction the whole number, I should have said less than 1 and then greater than 1. That's a little more specific, right? Right, because there are some fractions, like 4/3 to the x, that's going to grow forever. It's a fraction, but it's greater than 1, so it's going to grow forever. So then Michael, if I'm doing exponential growth, what's the limit of my function as I go to the right forever?
To infinity.
Yeah, and then to the left?
0.
0, yeah. Good stuff, good stuff. Cool. Cool. Good. Okay, let me know when I can move on. Some people are trying to catch up.
Wait, so how do you know the limits and stuff of each of them?
So growth, for one that's growing exponentially, it's going to start at 0 at negative infinity. As I move to the right, it's going to slowly grow until it just like takes off and it's going to shoot straight up to infinity.
Okay.
So you can look at any sort of growth like function. It'll look slightly different from this, but the end behavior is going to be the same. It's going to go to 0 as we go to the left forever. Okay. It's going to go to infinity as we go to the right forever. An exponential decay. So if we make this like 1/2. Right, that red decay graph, it's gonna be the same, it's gonna be flipped over the vertical. You see that?
Mm-hmm.
Alright, let's move on. Okay, so B, we want to find the y-intercept and horizontal asymptotes. How do we find the y-intercept of a function? It's not too bad.
0.
You just plug in 0. Okay, so there'll be 12 over 1 plus 2 times 0.8 to the 0. It's going to be 12 over 1 plus 2. It's going to be 12. This is 12 over 3, which is 4. Okay, so the y-intercept is 0, comma 4. My y-int. Okay. Any idea how we find the horizontal asymptotes?
That's not the degree one, is that? Is that the vertical asymptote one? The degree of the leading coefficient.
That's for rational functions. These are logistic functions. These are not rational functions. Anyone have any idea? All right, I'm pretty sure. Pretty sure I know what's going on. Just want to check real quick, make sure. That'd be bad if I muffed this. Yeah, that's what I figured. Okay. Good. Yep. Okay. So let's look at this. Okay. So I'm going to highlight just this part right here. Okay. Do you guys see how it's like an exponential function inside of like a fraction, like inside of a rational function? Okay. So 2 times 0.8 to the x. 2 times 0.8 to the x. Right. Is this a growth or a decay? It's a decay, right? Because the base is less than 1, but the exponent is positive. Well, it increases at least. It's increasing. Okay, so this is going to be a decay. Okay, what do we say the limits are for a decay? For a function that decays, what's the limit as x goes to positive infinity? 0. What's the limit as x goes to negative infinity? Infinity. Okay. So what's going to happen here? Okay. So there's going to be 2 different horizontal asymptotes. So let me highlight this in pink, or I'll highlight it in green actually. There's going to be 2 different ones. Okay. So as x goes to negative infinity, the horizontal asymptote is y equals what? Let's think about this. Okay, as x goes to negative infinity, what's that yellow part going to do? What's the yellow part doing? It's a decay. So the yellow part, as x goes to negative infinity, goes to infinity, right? Mm-hmm. So this is blowing up. The denominator of this function is becoming a huge number, right? It's getting bigger and bigger and bigger. So what does the whole thing become? When you have 12 over a number that's going to infinity, do you know what that is? 12 over a number that goes to infinity. So a small number divided by a big number gets really close to what? Gets really small, right? Gets really close to 0. So it's going to go to 0. It's going to be y equals 0. And as x goes to positive infinity, what's this yellow part doing? It's going to what? 0, okay? So as x goes to positive infinity, we can just ignore that. What does my y equal? 12. It's just 12. Okay. That's it. Okay. So you have to identify, right, this yellow, or this, I'll do it in yellow again. This yellow exponential in the bottom, you have to identify whether that's a growth or a decay. All right, and that gives you your answer. So it's 5 times 0.2 to the x. Is that a growth or a decay? Decay. It's another decay. Yep. So the limit, I'm just the yellow part. So it's the same thing here, okay? It's the same as these, okay? So I'll just let you read that off the board, okay? So the horizontal asymptotes then, the HAs, okay? HAs, right? Since it's a decay, as x goes to negative infinity, so as x goes to negative infinity, y equals what? JJ, you know what y equals as x goes to negative infinity?
0.
So this yellow part goes to what? As x goes to negative infinity, the yellow part goes to what? Infinity. So yeah, good job. Yep. And as x goes to positive infinity, Alberto, what does y equal? For this one, what's my horizontal asymptote as I go to the right forever? So let's think about this. The yellow part. What is the yellow? Just the yellow part. What does that do as x goes to positive infinity? What's that? Goes to 0. Okay. Goes to 0. So if that goes to 0 as x goes to the right forever, that just goes away. And then what are we left with? For y, 18. Yeah. Are you guys feeling okay about this? Don't forget the y in either. How do I find the y in? You just plug in 0. So 18 over 1 plus 5 times 0.2 to the 0. Which is 18 over 6, which is 3. So the y-intercept is 0, 3. We feeling okay about that? Cool. E. Or this is part C. Let's move on to part C. It's from the HAs. So as x goes to negative infinity and as x goes to positive infinity. Let's see if we can do this a little faster. Okay, so let's do Caleb Martin. All right, as x goes to negative infinity, what's my y going to?
Is it 0?
So let's think about this. Okay. So that yellow part there, is that a growth or a decay? So it's a decay, right? I think it's a decay, right? Okay. So it's a decay. Okay. Right? Yeah. Okay, so as we go to negative infinity, we're going to go to 0, so good job. What about as we go to positive infinity?
It's still me.
What?
It's still me.
Yeah, still you.
Oh, infinity.
So this is going to go, as we go to positive infinity, this yellow part is going to go to what? 0, right? You see that? So 2 times e to the negative, like 99 trillion, is like basically 0, right? So this becomes about 0. What are we left with, Caleb? It's like Caleb answer.
I have no idea.
All right, so look at it. You do have an idea. What do I have left?
No, I didn't even see the 9 on the top.
There you go, 9. There you go. Okay. And then Caleb, what's my, not let him off the hook, what's my y-int? What's my y-intercept? How do I find, you know how to find the y-intercept? How do I find the y-intercept of a function? I plug in what? Actually, it is 9 again, isn't it? No, it's not. Close, sorry. It's 9 halves, right? Or 3, yes, 3. 0, 3. Or 3, 0, 3. I'll get him next time. We'll get him next time. So to find the y-intercept of a function, you just plug in 0 for x. Okay, yeah. Just a minute. So you were right. This is, so let's look at this. 9 over 1 time plus 2 e to the 0. That's 9 over 1 plus 2. Alright, we'll stop there for today. So no homework, just study up on the test Thursday, okay? Office hours tomorrow in Mrs. Core's room. Mrs. Core's room, I'll be busy.
Do you want this paper? Because I take them based on
Are you feeling okay about what you're doing?
We got time. We got leave all the time until we're actually sessioning over that.
I think we're going for, I'll have to talk to this guy. I think it's like a couple weeks.
Yeah.
I didn't get my iPad to you.
I really didn't need to yet. It was just
You guys are enthusiastic, you know?
the meeting wasn't necessary to be there.
Okay, well then never mind.
They're never necessary to be there.
Would you have a gender class that you could just slave?
Not really. I wish.
Yeah,
Man, you must be so lucky.
I was just president.
When she asked you to be there, she's like,
Why to be up so early?
Well, I mean, I have to be here anyway, so.
It's at 8, but then if I bring kids before, then I have to get food.
yeah, I can't remember. It's all good. School started at like 7:25, my friend.
I don't have any of my friends.
Yeah, we used to.
It used to
It
start
started at 7:20. What's that?
Yeah.
Started at.
I mean,
We
used
start
to
seven-
start
there's only one.
7:40. I thought it was
7:40 was
7:50.
7:50 was like where like sophomore through senior.
Yeah.
I didn't press. I mean, I
And then we
had
had late starts at 8. Okay, well, what was this?
Maybe
We
late
got
start.
by 2,
We had late start.
started at 8.
And during COVID, we just had like online Mondays.
That's
It was so nice.
It was nice when it was best.
Weekend every
Yeah.
It's like a day for.
I mean, they have like.
go on like a 3-day thing.
Oh, like missing Monday, like the next day. Like, you know, we used to do like shambles Sunday.
Yep.
Like,
We're at this
Sunday,
thing.
Sunday.
Whoa.
Who was actually throwing Sunday function for me?
You could.
Yeah.
You could. If we were
Sunday
older,
fun day, because Mission Monday.
it was never had you.
Yeah.
If we were a year older, that would be
I'm gonna start wearing like,
Everybody like, if ever
This feels eerie. Are you good?
Tired. I'm so tired. I'm done. I'm not gonna hide it. No, I'll be fine. It's a really easy lesson today. Also, though, no one went to math league in this class. We had one person go to math league.
I was gonna sign up, but I didn't have $4, so.
And you had tuition money, but you didn't have $4.
Yeah. Not on me.
Not on me. A bunch of people did someone would give me a 20, and then 4 people would Venmo them.
Oh.
You got the quiz in here when? Thursday? Super far ahead in here. Not for the quiz, no. We actually have, I have to teach you the last lesson on this test. Someone sold these for me. Whoever it is.
This is kind of red.
Okay, you need to chill with that. You need to
Right.
I just put it. I just put it. What? What was it? Oh, I put it.
Yeah, look.
Yeah, Joey Canessa was the only one who came to math league.
Let's go, Ted!
What, you asked people what?
Wait, if I get 4 points for that, what do you do?
If I had 15, but whatever, 15, 10
Mr. Russia, even if I don't get one right,
I'd buy it now. If I had done
Mr. Usher, we got 30
I would,
so I
I'll
can.
go for
If you get them all right, I give someone that credit. You get them all right.
How many points do you get for that?
If you win, though, I'll take after risk stuff.
I think so.
What?
Alright, throw it.
Try me.
Entire year? Oh.
There should be, I think it should be 64 over, it should be 64 over there. So you just have to go back to 0.
Wait, Mr. Rector, would you have to win the cathedral students or out of the entire
Cathedral. If you won the whole nation, you shouldn't be in this school.
I just kept forgetting to print it out. That was weird.
Serious?
I did it online and then I kept forgetting to print it out.
Okay, well, I know I'm in.
why are you acting like you?
Yeah, so my reward, my sophomore year for winning athlete, was going to be building a big good service. I almost won.
I thought you did well. You lose,
I won my senior year.
You like that?
I actually didn't almost win my sophomore year. I was number 1 after the first.
I wanted that.
I was on top. I got a 6. As a sophomore, that's pretty good.
Mr. Usher, we can't come into office.
You can. So here's what's going on tomorrow. Mrs. Kors. Office hours for my class tomorrow are going to be Mrs. Kors.
What's the name?
No, you have to do Mrs. Kors.
I had like 2 things that disable it. Yeah.
Mrs. Kors. Call her Mrs. Kors.
I really want to say I cannot I'm very good. This quiz.
One day late.
It's 15
If I won my senior year, I didn't get taken. I was gonna fuck it up. I just made fun of Mr. Miller the whole year in that class. I did some like really unacceptable things.
Hey, you're a senior?
No, my sophomore year.
I'm still
It's not a reward. No, I mean it was on good fun. We were really pretty close. I was one of the few examples of like a kid who like to screw around in class.
Yeah, that's probably the habit. It's like,
There's a few of them. They do exist. And then the teacher's kind of like, you have an A in my class anyway. So. That?
yeah.
Yeah, you have to have an A to crush it.
I'm over the IU one this weekend. And then
Like, there's a girl named Precal who has like crushing it.
I
I just let her do her online shopping all class.
IU what?
Shopping all class. Alright, let's get the homework out, please. 5.7 homework out.
I got USC IU.
Yeah, how you doing? Okay, we can go now.
I don't know where they are.
Notes from today, I might be in our credit
birds,
You're still filming
You
that?
know how to factor today's notes are very simple.
They were like only 100 people at wrestling.
Go to the doctor.
Wait until I get you.
So you still dress?
Homework's an example.
That's their best schedule. That's their best schedule.
I'm going, Max.
Don't ever, no. Yeah.
Nah, they're sad.
Alright, Mr. Russell, what do you mean by this?
They're picking up
You signed?
They're picking up Tommy Lee.
It's a joke.
No, it's not a joke.
It is. No, it's a joke.
Tommy
Mr. Russell,
signed a contract.
if your most least favorite team picked up a really good player after the season that basically already started, just for them to be a stacked team, would you hate that or would you not hate that?
I hate that.
Exactly.
That's what the Dodgers do.
Exactly.
Hey, but what's up? The Dodgers are heating up.
They lost.
They just bought Max Scherzer mid-season.
Yeah.
That's what they bought.
Hey, Louis Buck.
Yeah, they bought you a 1 year.
We're getting Daniel here for the one.
No, you are not.
I was just talking with him.
Where did Danny go?
What?
Where's Danny from? Like, what school? St. Simon?
He said he doesn't want to play for St. Simon, so I offered him a free scholarship to San Jose.
Yeah, no,
Me
we
and Danny are re-signing together.
You guys should make it a little hat, like a signing day, have put a hat.
You play Marvis.
Oh, we lost it.
Yeah, but are they good?
Like there was this one, it was like 28 to 4 on the fouls, so just our fouls.
Yeah, I was doing that.
But he was doing skinny jeans.
He was wearing jeans?
Like 38.
And then they removed
Yeah, it was, yeah, sometimes put on jeans and put them up. Put them on skinny jeans, so he was wearing some tight shorts, but then he put on skinny jeans after that. Yeah, he had a ball, he was warming up. I mean, this kid didn't get a ball, he was dropping
I don't know why I still have this quiz. I'm sorry. I graded them extremely fast. I don't know why I still have them. I graded e-period quizzes before the period ended. Pretty awesome. I had them in the grade book. And I was like, alright guys, your grades in Power School, let's do the notes. scores were pretty good. Like median was like 90%. So this next one's gonna be way harder. Just so you know. JSYK. JSYK. He was wearing sticky We had a kid drop like 40 in one game one time when I was
Quinn
playing.
did. Quinn dropped like 100.
Quinn dropped.
I have 54 left.
He dropped 50. I love basketball.
Wow, he's knocking you.
That's such a joke.
I'm saying that was a joke, huh?
I'm a,
I didn't take that out of class.
It was a joke.
You know what I did? You know what I did? Because I did it against Iceland.
Yeah, she was like, yeah.
Our moms are like same meal. Our players were out.
yeah, okay, guys, the papers passed out. Sorry about that.
It's not hard to play.
All right. Phones away. AirPods out. Lanyards on. So, on the homework? Okay, talk to me later. Okay, we're busy. Phones away. AirPods out. Maggie, I have yours right here. Lanyards on, please. Lanyards on. All right. Oh my gosh, I never ended the pre-cal video. Oh, that's gonna be